Hi everyone, this is lesson 41 and we are going to be adding and subtracting fractions with common denominators. This lesson is a really pivotal lesson in your 5th grade math curriculum. This is a big step. So we're officially starting to combine fractions, and that work begins with combining fractions that have common denominators. It's going to be really helpful that your previous lesson, lesson 40 from yesterday, really reviewed what a mixed number is and what a mixed number looks like, because using mixed numbers is going to be the most appropriate way to write your answer when your result in doing this work gives you an improper fraction. So in the case where your answer, when you add or subtract two fractions, when your answer has a numerator that's bigger than the denominator, we never leave our work like that. That's incomplete. It's not the most appropriate way to leave your answer. So understanding how to take that and turn it into a mixed number. Without further ado, let's take a look at our learning target for today. There's just one: add and subtract fractions and mix numbers with common denominators. Okay, so just a little bit of information here. Adding and subtracting fractions with like denominators, that's another way to say that. Common or like meaning the same. If the denominator is the same, add or subtract the numerator, the number on top. Keep the denominator the same. That stays constant. You don't touch it. That stays how it is. So take a look right here. We have 1/6 plus 4/6. Our denominator is the same. We're not going to touch that. We would just add the numerators right here on top. We would end up with 1 plus 4 is 5. We would get 5/6. I'm just going to write that really quick right here. 5 is not bigger than 6. This cannot be reduced. That is the most complete answer. Let's take a look right here. We have 3/4 minus 1/4. Well, first of all, we check right away, are the denominators the same? Yes, they're both 4. Then we work with our numerators. I'm just going to bring that right over. Okay, 3 minus 1 is 2. We've done perfect work, but we notice right away this fraction, before we ever finish our fraction work, we ask, is this the most simplified form, or is this form appropriate? 2/4 can be reduced. 2/4 is the same thing as 1/2. That happens to be a fraction I just know in my head, but really what I'm asking myself, excuse me, is, do they have a common factor? Do they have a number that they can, a factor that they can divide by to minimize this fraction or to simplify this? 2 divided by 2 would give us 1. I'm just going to write this right here for note's sake. We're going to divide the top and bottom, numerator and denominator, by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. That's where I get my 1/2. Excuse me. Let's take a look at this example. Draw out the following problem to illustrate this addition. Then write a number sentence for the addition. Go ahead and pause your video and give this a try. Try drawing it out. It's a good method when you're starting your work with fractions. And unpause when you're ready to check my work. All right, so I've drawn a diagram, I guess, to show this number sentence. I have 2/4, or 2 out of 4 quadrants shaded in here, plus 1/4, so 1 out of 4 shaded in, and my result was 3/4. Just to do that in an equation, I would just take a look back up here. We have 2/4 plus 1/4. Our denominators are the same. I'm just going to bring that over. And if that's the case, I just add my numerators. 2 plus 1 is 3. 3 isn't greater than 4. I don't need to turn this into a mixed number or anything, and this cannot be reduced. 3/4 is my answer. So I have 3/4 here and 3/4 here. Here's another one to give a try. Solve the following problem and write a number sentence for the subtraction. Draw a picture if needed. Give this a try and unpause when you're ready to check my work. So in this case, I didn't really feel like it was necessary to model a diagram again, since I just did that in the previous problem. And as far as writing a number sentence, I'm just going to work with the equation that they've given me here and just work on solving that through. I don't need to rewrite that. So the first thing I'm going to do is read the problem. I have 7/10 minus 4/10. First thing I go and take a look at is, are my denominators the same? And yes, they are. They're both tenths. So I'm going to bring that over. Now I can just work with my numerators, and always make sure when you're doing this work that you're really double checking what operation they're asking you to do. In this case, the operation we're doing is subtraction. That's another thing that seems really silly, but it gets commonly missed. So really making sure if it says subtract, you're subtracting and not adding. So we have 7 minus 4. Well, 7 minus 4 is 3. So this is where I'm at. I have 3/10. So I'm going to ask myself, first of all, is my numerator greater than my denominator? Do I need to turn this into a mixed number? No, 3 isn't greater than 10, so that's good. And can I reduce this at all? 3 out of 10. 3 and 10 don't have any factors in common. In fact, number 3 is a prime number. It doesn't have any factors in common with anybody, or any number, I should say. So 3/10 is my final answer. Example 3. Bak Yen mixed 1 1/4 cups of juice concentrate with 1 2/4 cups of water. Find the total amount of juice by adding 1 1/4 plus 1 2/4. Give this a try. Unpause when you're ready to check your work. All right, so I've actually set the problem up this way, because this is a common way that you are going to see problems like this in your math assignments, and it's just a good visual for you to see this. Vertical, stacked on top of each other. When you see problems like this, it's really important that you remember that the first thing you're going to do is work with your fractional parts. The whole numbers will come second, but you're going to work with your fractional parts, meaning you're going to start on the right. You're going to start here. And just as though we were looking at a linear problem, we're going to double check and make sure that our denominators are the same. So let's look here. We have 1/4 and 2/4 that we are adding together. Our denominators are the same. Let's set up our fractional part right away and bring down the 4. If they're both the same, we can just carry that down. That means the denominator stays constant. It's there. Now all we have to do is worry about adding our numerators together. We have 1 plus 2. That gives us 3. That fraction looks good. 3/4, can't reduce it, can't do anything with it. I'm going to move on to adding my whole number parts. We have 1 plus 1 is 2. We've created a mixed number by adding 2 mixed numbers together. We have 2 3/4. Looks good. Another example here. There were 2.5 chicken pot pies. What is with all the pot pies? This is kind of funny. In the refrigerator, Tupac ate 1.5 pot pies. To find the number of pot pies left in the refrigerator, subtract 2.5 minus 1.5. Go ahead and do this work, and unpause your video when you're ready to check your work with mine. I'm laughing because I don't even know if you all know who Tupac is. Okay. All right, so I've gone ahead and stacked this. I've created a vertical problem just like the one I did previously, and we're going to start this work by looking at our fractions. So we have 1/2 minus 1/2. Just saying that out loud makes me realize 1/2 minus 1/2, anything subtracting itself, anything minus itself is going to result in 0. Just like 1 minus 1 is 0, 1/2 minus 1/2 is 0. So I'm actually going to end up with nothing down here. But in case you didn't pick up on that right away, here's what would happen. We would look and say, well, our denominators are the same. Let's bring that down. Now we can work with our numerators. 1 minus 1 is 0. And the truth is you can't write a fraction like that. A fraction with a 0 in the numerator's place doesn't exist. 0 divided by 2 is 0. So we just don't write it at all. We're going to just scribble that out. That doesn't exist. No fractional part. 2 minus 1 is 1. The answer is 1. Just for the sake of bad handwriting with a mouse, I'm just going to write pi instead of pot pie. 1 pi remaining in the fridge. Last example, I promise. Federico estimated that it'll take 2.5 hours to finish reading a book and 1.5 hours to write a book report. To find the amount of time he needs to finish the entire assignment, add 2.5 plus 1.5. Try this and unpause when you're ready to check my work. So this example for me is actually one that probably can be done mentally because halves are easy to work with, right? So if you were able to solve this mentally, awesome. There's not a way for me to really model how to solve this mentally, so I'm just going to go through step by step still and show how to solve this as an equation. So I've stacked this vertically right on top of each other. I'm going to begin this work by looking at my fractions. So do my fractions have a common denominator? Yes. So let's bring that down right away. It's 2. Now I can work with my numerators. I have 1 plus 1, and that's 2. Right away, I notice something about this fraction. I can't leave it like that. Any fraction that is a number on top of itself, or where the numerator and denominator are the same exact number, that fraction is worth 1. So I know that 2 seconds, or 2 over 2, when we look at this, that is the same thing as 1. I'm not going to fix that quite yet, but I'm just going to remember that before my answer is complete. I need to switch that. Now that I've worked with my fraction, I'm going to add, double checking my operation, I'm going to add my whole numbers. 2 plus 1 is 3. 3 and 2 halves is the same thing. If we consider this as 1, that's really like 3 plus 1. And the most appropriate way to write my answer is 4. Now, this was a story problem or a word problem. Let's go back up and double check what our label should be. I think it's hours. Hours, yep. 2.5 hours, 1.5 hours. We're talking about hours here. I'm going to kind of abbreviate that a bit. 4 hours total. That's a big project.